Hello, it's Duncan. I'm on holiday and have COVID, so my AI alter ego is reading this for me. He's Australian, but I'm choosing to find that endearing. Our excursion into creating JVM proxies that allow us to delegate suspend functions to non-suspend functions ran into the buffers of the Java module system last week. We found that we couldn't call public methods implemented by private classes in another module. That's annoying, but it's the nature of reflective code that we often have to wheedle the JVM into doing our will against its better judgment. A lot like dealing with a development team or an LLM. We have to find the right incantations to prove that we are worthy of a system that does what we want it to. So today, let's see if we can write our own version of some of the magic behind Spring and other reflective frameworks.
So in fact that is sensible, and I will let it live. We left the last episode with a bit of a conundrum, which is that our structurally typed as, this extension here, which allows us to call through an interface like myCollection into methods with the same signature on a wrapped object. That works fine like this. But if instead of using an array list, we use a Kotlin, well, the result from Kotlin list of, it fails. Now it fails because we threw in this handler here, and the reason we threw is this illegal access exception. And if we look along, it says, class structural typing test cannot access a member of class Java util array list with modifiers public. And looking here, that's happening on proxying at line 20. So we found a matching method, but we've thrown an exception when we try and invoke it. Now that normally happens, this illegal access exception, if we're trying to call a private method. So let's go and see what we're actually finding. So I think we'll set a breakpoint here and debug this code. Okay, here we go. Here's our matching method, and you can see it comes from Java util array list, and it has a name of size, return type of int, all the things we expect. It has this modifiers 1. I wonder what that means. Well, it comes from method.java and it's a good old-fashioned int. Let's see if we can work out how to interpret it. And find other places this is used. Things like modifier is static. Let's have a look at modifier is public. Here we go, set of fields. And private is 1. So in fact, this looks like it is a public method. And in fact, if we go back to the debugger, I think we might be able to evaluate. Is public? No, we haven't got that. Maybe we can say modifiers, if we import that, is public matching method as method dot sci dot modifiers. Evaluate that, and it is true. Okay, so we're trying to call a public method, but it's throwing. This took me a while to work out, and the clue is sort of hidden. This is not Java util array list, this is Java util arrays array list. And if we trace through what list of creates here, you'll see that it uses elements as list. Elements as list returns arrays util JVM as list, which returns arrays as list, which ends up calling array list, but confusingly not the one that we think, this one here, which is a private class inside arrays. And now I can see why you'd call that array list, but I can't see why you'd call it array list given that you've already got an array list. But the key thing is that this is private. And because it's a private class, we can't call this method on it. I think that may only have been true since Java introduced the module system. I don't know, to be honest, but it's a bit of a pain right now. Given this private array list extends abstract list, which is a list, and we know that this list has a function called size that returns an int to match this, then we know that there is a method we can call. It just isn't the one on the class, it's the one on the interface. Now, if you're used to Java reflection, you might think, well, we can just call setAccessible on it. And in fact, these days, there is a method try setAccessible, which returns whether it succeeded. Let's find out by printing that and run. Oops, this should be matching method try setAccessible. Run that. And apparently setting accessible has succeeded, but it still failed. Just as a matter of interest, is matching method accessible? Yes, it is. So all the traditional signs were that we'd be able to call this thing and that this would succeed, but it turns out not to. There is in fact one clue, which is println matching method dot can access. And if we give that to this and run, oh, there's something very strange going on. Why is that false this time? This has been happening to me a lot in this project, but I'm not running the code that I think I am. Well, let's just try then. Try setAccessible. Run that. And we're now getting false, false. So in fact, the method we're getting back isn't accessible, but maybe matching method can access is a better test. So what do we need to do? Well, we've got this T class, and somewhere in this T class, or something that this T class implements, or I suppose maybe in fact a superclass of it, we're looking for a method with this signature that we can call. For simplicity, I think I'm going to split that into two tasks. One is finding all the types that a T is, and the other is going to be looking through those types for a method that we can call. Let's think about the first one in tests over here. So I'm going to go to test, and we'll call this find supertypes. So let's say I start with a string. I expect the superclasses to be list of, well, let's include ourselves, so that'll be string class.java. And then at the very least object.class.java will be at the top. And in the middle somewhere, I expect there to be char sequence and probably iterable of char and so on. We'll correct this later, but for now we can say assert equals list of that thing. And I think probably we'll go to its type. So we'll say class.java dot, maybe we'll call it types. Okay, so how would we implement this? Let's create an extension function in, well, there I suppose, and it's going to return a list of class of any. Yes, I think that's good enough. But as there's no relationship between that and that, I think we could probably say this is class of the star and get rid of that. Now, a nice way to implement these sort of collectors in Kotlin is to give this an optional parameter, and I think I'm going to call it so far, and that's going to be a mutable list of the things that we found. And I suppose that's probably star there as well. And in order to get this one to compile, we will default that. So that will be mutable list of nothing. Now then, first thing we're going to do is we're going to add ourselves, the receiver, into this list. So we say so far.add this. So in the case here, where we're starting with string, that will put string into the list, first of all. Now what about interfaces that we implement? Well, we can get that from this dot interfaces. And they're all types that we are, so we can add those. So far, add all this interfaces. While we're there though, those interfaces may have super interfaces. So we'll say this dot interfaces for each, and we'll get each one of those things to find all its types, giving it so far so that it can populate it. And then each one of those interfaces will do the same for any interfaces that it implements, and so on all the way up. Now then, what about our superclass? Well, that's this superclass, unless we're object, in which case we've reached the top. And in the case of object, this superclass returns null. So we can go back and we can say, if this superclass equals null, then everyone is populated so far, so we can return it. Otherwise, we can ask this superclass all types for passing it so far. And that's what we're going to return. Let's see what we get. Okay, so we expected string char sequence object. We got string serializable, comparable char sequence, constable, whatever that is, const desc, serializable, and so on. Right, let's see them all. another serializable, another comparable, another char sequence. Aha. So we have an issue here where an interface can appear multiple times. I think the same thing to do is to say, when we finally bail, we'll say to set. And that gives us a better definition, I think, that we want a set of classes. Change that to set of, run. Let's see how we're doing. So early on we should have put in serializable compatible, and then we have all these others finishing an object. Well, that looks reasonable to me, so let's just remember serializable and comparable to get us closer. I think I'm just going to take these two out of here, put them into here. So they went in here as Java lang constable class.java and Java lang constant const description class.java. Are we good? We are. And now the tests are passing. We can refactor a little bit. We can lift the return out of there. Reflection code can often be slow. If we have a look at this.interfaces, we see here we're cloning the interfaces before we pass them back. So I wonder whether we should pull this out into a variable of interfaces. Still good. Still good. And we might do better about the order these come out in, but I think that will do for now. So let's take this and put it over here as, let's say, internal, so we can keep our test of it. Good. And now we'll run all the tests again to remind us that we still have one failing. There we go. But now, instead of looking for a matching method just in this type, we'll look for it in all of its types. So we'll say val all types is this Java class all types. We have an annoying issue with inline functions not being able to call internal functions. We'll come back to that in a minute and just make this public for now. Okay, now we have a bit of a problem, which is that so far we've only dealt with methods that are actually there. We've only dealt with a class that does have a method with the right names and parameter types. It turns out that if we can't find a matching method, then get method doesn't return null, it throws no such method exception. Well, that's a bit of a shame, but I haven't actually found an API that allows us to ask the question, does a method exist, without throwing an exception. So I guess what we'll do is we'll just create ourselves a little utility, which is fun class star dot method or null, taking a name and parameter types and returning a nullable method. That was a good completion. And this will say, as it's saying here, try get method, catch, no such method exception, and return null if we get one. And now I think we should be able to say that we want all types, map not null, it method or null with name and parameter types, lost the name. And now we want to find the ones where it, the method, can access the object that we're interested in. Now, in fact, that's going to be a set of matching methods. I do wonder what to do if we find more than one match, but for now, I think we'll just say, instead of filter, we can say single, which will give us a runtime error if there's more than one. Okay, I think there's a chance that will work. Let's go. Aha, in fact, we do have collection contains more than one matching element. So we'll back out. We'll say this is matching methods. So here are all of the matching methods, all of the different sizes, but I removed the it can access this run. And there we go, splendid. So we have all these places that we could call it from, and we call it from the first of those. I think given the virtual nature of the JVM that they are all equivalent and it doesn't matter which one we call, but reflection is full of surprises, so it wouldn't surprise me if that did come and bite me at some point in the future. But now we can take out that, and I think it's also true that we can tidy this up a bit by saying this is class, lay that out, join that, and then if that isn't null, we can take if it can access this, allowing us to get rid of the second filter. Is that true? Splendid. So until we find another problem, we're almost done. I do, though, just want to document what happens when we can't find something. So here we're calling structural typed as where all the things on my collection exist. What about where a method doesn't? So this is going to be method not found. So now instead of my collection string, I'm going to build another one of those, which is my collection 2, and let's just add a fun no such. So now list of banana and kumquat won't have a no such on it. So if we try and structurally cast a my collection 2 string, what will happen? Well, at the moment, it's all fine because we haven't tried to call it. But if we do try and call it, we expect that to blow up at runtime. Let's have a look. And it does. And where's it dying? Well, this list is empty, suggests that it's dying here on this first. It's a bit of an unfriendly time to die, really. What I think I'd rather is that this wrap structurally typed as didn't succeed, rather than only discovering later on when we try and call it. In other words, what we want is that assert throws something, let's say no such method error, which is unchecked, when we try and call that. So we know that that doesn't happen at the moment. How do we make it happen? What we're going to do is we're going to do the work before we create the new proxy instance. So in here, we will make this a block body, and we'll make a lookup from this T to the implementing thing in this any before we return a new proxy instance. So that will be, we want lookup to be a map from one method to another method. Now we'll go to everything in our T class.java and find its methods. Each one of those things we want to map, and we want to do what we did here. I think if we make this a variable, then this thing is our lookup. So let's make a method out of that. And now I think in here we can use this dot method. I don't just want map, I want associate. So I want it to this dot method of it. And now when we're actually called, we can use the lookup. So I think in here we can say lookup this method and invoke it. Now, given that we've looked everything up, that should always succeed. For now, I'm going to bang bang and see whether this passes. Well, it doesn't pass because we're not throwing the right type. We're throwing no such element exception because of this first here. So let's have a bit of a tidy up. I think we can make this pass by saying first or null, question mark, throw no such method exception, method name. So we'll return that and see if that does work. Oh, we said error, it says exception. I think error is probably the thing we want. Good. Now I think we can take this out and say that if that goes wrong, something like that, that's an error in our logic because we have looked everything up by here. This associate can be associate with, and it's a bit inefficient to have to keep on doing this Java class all types every time through this associate. So I think we can say that this is going to be a parameter. Now make this a parameter. Make this the receiver. And now we can pull this out as a var. That's all of our types. And tidy this thing up by calling this method matching and rename this to be that can access. Add in the name of that parameter a little bit of reformatting. It would be clearer if that was this, and reasonable if this thing was a variable. So all of these are proxy type. Is that good? It is. And now finally, if we move that to the top, then we can make a function out of this, which is also called structurally typed as, inline that. And this doesn't need a reified t, and so it doesn't need to be inline. And now this isn't inline, this can be private. And this can be private. And this can be internal because we tested it. Inline that. Make that an expression body. Put those on separate lines. Do whatever IntelliJ tells us to do to fix that. Goodness me. First not null of or null. I'm not sure that's any clearer. I think maybe I preferred mine. Is that all good? It is. And that is an expression body. That cast can't be checked. That's all right. That I just want to get rid of. And are we still good? Splendid. Just add, suppress that unchecked cast for this option. Look back at our tests, and I think that test is a good one, and this should say throws method not found on creation if it can't find a match, and run. Brilliant. In fact, it occurs to me that if I accepted the merge call chain, then we'd be doing a lot less work, because we wouldn't be finding every method that matches, we'd only be finding the first one. So in fact, that is sensible, and I will let it live, given that it passes the tests. A tiny little form thing, I wonder whether we're better off moving this throw up. So if I take that out of there, make this return nullable, and that would allow us to see in here how we were failing. So that would say we'd that, and this would be it.name. I guess this is clear if we call this proxy method. Are we still good? We certainly are. And finally, we can check where we came in with all this. First of all, we wanted to take, for example, this third-party customers and structurally type it as our customers. Well, let's check that that runs. And it seems to be fine. That's good. And then finally, where we really came in, which is whether we can implement this co-customers here in terms of our actual in-memory customers. So that would be val co-customers is our in-memory customers structurally typed as co-customers. Try again. We failed. Well, I'm getting tired, but let's just go and see what we're facing. Structurally typed as, let's put a breakpoint in here and at least see what we're dealing with. I'm just going to go back and move this up to the top. So it's the first structurally typed as. So we try and run, debug. There's our proxy type, co-customers. And let's just have a look at proxy type.methods. And here we see that each one of the suspend functions has a hidden parameter of Kotlin coroutines continuation, which is in each case the last parameter. So our actual interface was here, list with no parameter, but a suspend function takes a continuation. Well, it looks like we've still got a little bit of work to do, but we're tantalizingly close. If you'd like to see whether we finally make it, then please subscribe to the channel. Click that like button because points mean prizes. And if you haven't already, you can reward yourself for sitting through this by buying a copy of the book that I wrote in that price called Java to Kotlin Refactoring Guidebook, details of which are on the show notes below. Thanks for watching.